Shukran, Masar here. It's very nice to be here. As you said, I'm working for UNIDO. UNIDO stands for United Nations Industrial Development Organization. Let me just say that our mandate is to promote and accelerate inclusive and industrial development for developing and economies in transition. For that, we have one of our aim is to enhance or safeguard the environment. For that, we're actually, we're working with multilateral environmental agreement, meaning the three most important one are the Stockholm Convention on reduction of persistent organic pollutants and the Minamata Convention on mercury reduction and CICAM. And for that, because we are directly working with industry and private sector, we are promoting approaches. One of our approach is a green chemistry. So let me give you some ideas of what the work we have started so far. Okay, what is green chemistry? And green chemistry is design of chemical products and processes to reduce or eliminate generation and use of hazardous substances along the life cycle. Of course, you might say, okay, this approach is not new. At least it started in the 1990s. However, as a UN agency, we're actually helping private companies to fulfill environmental conventions. As such, actually, we learned that there's a big gap between scientific availability of green chemistry alternative or environmental alternative and actually the practical implementation. So for that, there are 12 green chemistry principles which we are promoting. So where does green chemistry start? It's starting at the design and process. And that is actually about decision making. Because when you're designing products, you have to make decision about the type of resources you're using, which material you're using, which kind of feedstock. Are you using renewable resources or non-reusable resources? How much material is needed? Is it available? Which kind of solvent are you using? And so on. And also you have to make, as a private sector or industry, you have to make decisions about the manufacturing process. What kind of technology is needed? What is the scale? So all these decisions automatically characterize the waste stream in energy requirement and especially the toxicity of the process, meaning which kind of toxic chemicals are actually you using and what opportunities are there to reduce those chemicals. When it comes to green chemistries, we're promoting 12 principles. And these green chemistry principles go along the life cycle of material extraction and processing, manufacturing, use, and on end of life. Here you can see the 12 principles. The first one is, of course, prevent waste. Then there's at-home economy. Third one, using less hazardous chemical synthesis. Fourth, designing safer chemical products. Fifth, use safer solvent. Sixth, design for energy efficiency, especially when it comes, for example, to CO2 reductions. Then the seventh, renewable feedstock. 8 and 9, using catalysts, meaning different kind of more environmentally sound solvents, or design for degradation. Let me say, for example, when it comes to Stockholm Convention, and we work on persistent organic pollutants, for example, we were working on some brominated flame retardants. So those ones are actually resistant in the environment. So we are aiming to have some green chemistry solutions which do degrade over time. And then two more principles would be the real-time monitoring process. And of course, we heard a lot about using safer chemistry to avoid some accidents. So what are the benefits of green chemistry? As you said, those all might be feasible, but actually when it comes to reality, especially in developing economies in transition, for many private sectors, this is not the case. For example, and the benefit would be, of course, for the environment and human health, not to use toxic chemicals, which will end up, for example, in the food chain or in the environment. So those chemicals which actually do not persist in the environment. Then also when it comes to economy, those novel products or innovative products might boost the competitive among other industries or companies. And of course, not using hazardous materials has a big economic benefit of reducing costs. For example, you would not have to store the hazard chemicals, you would not have to receive health requirement, and especially we also be dealing with the end of life or the final disposal, which is very cost effective, and also there's a lot of risk associated with it. And then, of course, for sustainability, using products made from renewable resources are preferred. And then for science, it is also new insight, actually, because as we learned, there are lots of green chemistry alternatives available. However, the practical implementation is quite limited. So let me give you 3 examples. And the first one is for principle number 3, using less hazardous chemical synthesis. Here we are aiming, whenever practical, to use scientific methodologies should be used that pose little or no toxicity to human health in the environment. Ideally, non-toxic substances should be used to synthesize its chemical products. One of the examples, which is actually very known by now, is paper bleaching. What we of course also aiming, because we directly dealing with private sectors, that we're not only we're trying to support supporting or using a green chemistry, we also need to ensure that the process is still efficient by converting to a green chemistry alternative. So for example, when it comes to conventional paper bleaching, usually it was done with chlorine dioxide, which of course produce a lot of toxic chemicals as a waste product. So alternative technology for paper bleaching would be with hydrogen peroxide, which provides lower temperature and also time requirements. Then the second example would be for designing safer chemicals. So chemical products should be designed to preserve efficiency of the function while reducing the toxicity. Today we have heard a lot about the risk. So green chemistry is focusing on reducing the hazard, to ultimately reducing the risk of releasing toxic chemicals to environment and to human health. So when it comes to designing chemicals, we are promoting, of course, to avoid those hazardous chemicals. As I mentioned before, we're working especially for the Stockholm Convention to reduce persistent organic pollutants, which at the moment there are 29 chemicals listed, or mercury. So those ones, of course, are persistent or long range available in the environment. So we are promoting, of course, to use some chemicals which have not those properties. One of the examples, actually DDT, is listed as an agricultural pesticide in use for malaria control. This chemical is also listed under the Stockholm Convention. So this is one of the examples where actually the use is this kind of restrictions still allowed, because the alternatives they are available, but there are many barriers why companies or countries can actually not use the alternative. So for DDT, there's a green chemistry available. This one would be a national product for insect control as an example. So our aim is, of course, to promoting or to support companies to help and to use this green chemistry alternative. Then when it comes to principle number 12, today we have heard a lot of accidents prevention. We have heard a lot about the bio-explosion ammonia, but also when it comes to the Stockholm Convention, we're dealing with, for example, brominated flame retardants. So the idea is to have substance in the form of substance used in chemical process should be to minimize the chemical accidents. One of the examples would be, for example, in airplanes, the polymers. This is the case of airplanes, but also in cars, where there's a high amount of polymers used, and in those polymers are brominated flame retardants, which are listed under the Stockholm Convention and should not be used further. So there are actually available alternatives which could be used, which would then actually prevent an accident to be exposed. So last thing is, at the moment, we are working on a global green innovation and network program. Our funding is the Global Environmental Facility, which is the main funder for the Stockholm Convention or the Minamata Convention on Mercury. We have a pre-approved project available. So we're working together with Yale University, which is in New Haven, United States. They're very prominent working on green chemistry and green engineering. And we're working with 6 countries together on that project, which would be Jordan, Peru, Serbia, Indonesia, Uganda, and Ukraine. The aim of this project is to scale up green chemistry for persistent organic pollutants, and especially mercury, through capacity building, innovation, creation of a unified green chemistry network. As you can see here, we are working on national, we have national components, but we're also working on the global scale. This program has 4 components. The first one is a global green chemistry inclusion network for capacity building. So it concludes a network beyond awareness raising and training for developing countries, those ones which I mentioned. Then component 2 is a green chemistry accelerator program. I think that is very important so that we give startup companies an opportunity to bring their green chemistry to the market. So this one will support the development of a demand-driven solution to supporting the benchmark scale-up green chemistry in green engineering. And then we have a component 3, it's about demonstrating the green chemistry alternative for persistent organic pollution mercury in the countries. So they're actually trying, as I said, bridging the gap of lack of actual practical implementation of green chemistry. So we're demonstrating in each of the countries mentioned a green chemistry alternative. So this could be, for example, for brominated flame retardant, or for PFAS in the textile sector, or for short-chain chlorinated paraffin, for example, in the textile.
You have 3 more minutes, Maren.
Okay, perfect.
All right.
Thank you very much. So that is just my slide at the moment. As I said, this project is in a concept state, so this is approved. At the moment, we're working on a so-called preparation phase, and we're aiming to submit this project within the next year. So when it comes to Jordan, I think it's also very important today that I have learned a lot of different industry or even a bromine, and to pay attention to that project. This is all what I would like to say. I am working on the headquarters, which is in Vienna, Austria, but also we have a UNIDO office in Jordan, and you can see here the email, and please feel free to contact us. Thank you.